All right, pre-AP Monday, we're talking about area of triangles. First, we're reviewing what it talked about in the flip lesson in terms of the types of pi. It told you about 3.14, and this is like our default setting. When it asks us to find the area or the circumference or anything where it has pi, if it doesn't specify otherwise, we will use 3.14. So because it's that default, this is also the most commonly used. Okay. The second kind that it talked about was if we put 22 over 7. Again, if you put that into the calculator, it will end up being 3.142 something, something, something. It ends up being a repeating decimal, but it's a very close approximation of 3.14. And the times we want to use this is when our radius or diameter is a multiple of 7. Okay, and I'll show you why. Okay, so for example, if I have this circle and it says that this length right here is 14. First of all, that is the what of the circle, Marcella? The radius. So if I was finding the circumference, I'm sorry, this is being weird. It would be C is equal to 2 pi r. So C would equal to 2 pi times 14. We can simplify that further to say C is equal to 28 pi. And then again, because this is a multiple of 7, I'm going to show you why we use 22 over 7 as pi. When I do 28 times 22 over 7, I would have to put 28 over 1. And then I can always, if this value is a multiple of 7, I can cross simplify. Okay, and this will always go down to 1. So I just have to worry about my numerator, which would be 88 over 1. And again, it's just that here. This doesn't really work. It's not really helpful if it's not a multiple of 7, because then I wouldn't be able to cross simplify. That's the only reason why you really want to. Okay, and then the last one it says is just 3. Okay, they said to use this either in estimating, because you would round it down, or to use it in a multiple choice question. Okay, so why would we want to use this in a multiple choice situation, Andrew?
Because like sometimes the choices, like in the Canvas quiz, there was one like that. It's like there was a huge difference in between the numbers.
Mm-hmm.
So if you multiply it by 3, then you know the number that you got is the actual number is more than that number. So
yeah. So again, so what he's saying is that usually with the answer choices, they'll be like really drastically different numbers. Like normally where you're like, how did they get 22 or 7 or something like that? When you multiply by 3, it will get you still close to the answer, but the actual answer will always be a little bit more, because if we go from 3.14 to 3, we're rounding down. So our answer is actually going to always be just a little bit bigger. Does that make sense? No feedback. Okay, so let me show you an example. If I had a circle and it said that this was 5, so C equals 2 pi r, C equals 2 pi times 5, so that would equal 10 pi. If my answer choices were this, 29, 32, 10, and 5. What would be my best answer choice? Jalen? B. Why?
Because it's probably the closest to 10 times 3.
I would say 29 is close too, but why is that one not the answer?
Because the answer is 3, so 3 times 10 has to be at least 30.
It would be 30, but that would be, this would be too low, because I've already rounded down, my answer's not going to be any lower. It would need to be higher. Miles? Yeah. Yeah. It would be 31.4, which again is closer to B. It's always just a little bit more. Okay? So, you can, for today's lesson, we're actually going to be watching a video, because what it says and describes and shows you is a lot easier to see with this video. And so I'm gonna play it. I'm gonna have it play in the recording so that they can see it. Okay? Yes, Addie. We're gonna watch the lesson first. Okay, remember we're still recording.
Area of the circle. But where does pi r squared come from? First, we'll draw a circle and fill in its area. Next, we will divide it into large equal parts and arrange them in a rectangular formation. As you can see, it barely resembles a rectangle. So next, we will divide the circle into small equal pieces, and we will arrange them in the same manner. You can see that it appears more like a rectangle. So, if we divide the circle into even more smaller pieces, you can see that every time the shape becomes more like a rectangle. So, how small must we divide a circle before we can get a perfect rectangle? Well, we can keep on dividing the circle into small, smaller, or the smallest pieces you can make. But the answer is to divide the circle infinitely many times until we cannot distinguish the lines, and eventually the circle can now become a perfect rectangle. So, the area of the circle is equal to the area of the rectangle, which is equal to base times height. The height of the rectangle, as you can see, is the same as the radius. So height is equal to radius. To find the base, we need to look at the circumference of the circle. And when we compare the base and the circumference, we can see that the base is equal to 1/2 the circumference. Remember that the circumference is equal to 2 pi r. When we combine it with 1/2, the 2's cancel out, and the base is equal to pi r. So now, base times height becomes pi r times r. Combine the r's together, and we have pi r squared, which is equal to the area of the rectangle, which is equal to the area of the circle. So pi r squared can be used to calculate the area of any size circle that exists.
Alright, we'll have that linked in the Canvas for today in case you want to watch that over and over again. Okay? So, we're just going to write that down in notes. Again, that video just helps you visually see it a lot better than I could actually ever do because I can't cut those small pieces. Okay? So, again, you could do it with a paper plate if you wanted to get home, but I didn't want to make the mess in my classroom. So, we're just going to skip ahead. What expression represents the base of the parallelogram? What did they say was true for that? Timothy?
The base is equal to half the circumference.
Half of the circumference. Okay, but then Miss Lytle, where does the other half go?
To the other base.
To the other base, the other, like the top part of it. Okay, so that's the whole circumference. So again, just like triangles last week and trapezoids, everything's sort of built off of that rectangular formula of base times height. So when they found that base was actually equal to 1/2 of c, what you can then do is take the formula for circumference. We're going to use the one that's 2 pi r. And again, I can see what little shortcuts I can take. I can cross those out. So half of c is the same thing as just pi times r. Then for the height, okay, again, we just changed b into pi r. But for the height part, that's this. The height of this parallelogram, again, if you put that back into this triangle, or sorry, into this circle, the height is equivalent to the what of the circle? The radius. So that would be times r. Then, as we learned earlier this year, any number times itself, any variable times itself would just be squared. That value squared. Okay, so that's how they got pi r squared. Okay, so again, if we were filling that in, this is talking about half of the circumference, and the height was the radius. So if you took A equals BH, that would become A equals pi r times the radius, and then lastly, most simplified, pi r squared. Okay? Now looking at our star charts, if you have them out, let's see if there's two formulas for area. There was two formulas for circumference, but I want to see what happens. Are there two with the diameter? Like, is there a formula where they use the diameter instead? No. Okay. The answer is no. There is not one. So what would I do if they gave me the diameter of a circle and they wanted me to find the area? What would I just do? Of course,
You would multiply it by 2.
No. If I was trying to find the area for this, but they gave me D. What if they gave me what D was equal to, Saranya?
You would just multiply that by 3.
No. Peter?
You would divide half of B.
Yes, you would divide the diameter by 2, which would give you R, and then you can put that back into a formula. Okay? You can't just divide it by 2 at the end. You have to divide it by 2 at the beginning before you do anything, before you do the square.
So you would divide it by 2 and then multiply it by 3.
Yes. Yes. Okay? So looking at this, Adrian bought an 8-foot leash for her dog. How much running room will her dog have access to? So it's saying, like, if your dog was on a leash, usually it's attached to like a pole, and then this part is 8 feet. And that is the what of the circle?
Radius.
That's the radius. So over to the side, I know your notes are really dark. I would probably put 8 is equal to the radius. Whoop. That says radius. 8 is equal to the radius. Now, ask yourself, are we looking for this distance around? Or when you're on a leash, can you run in all the spaces in between?
All the spaces.
All the spaces in between. Because nowhere here does it say, oh, find the circumference. It doesn't say find the area. It just says how much space does he get to run around it. So we need to find the what of the circle? The area of the circle. Okay, so we're going to start with that formula. A equals pi r squared. Substitute and solve. A is equal to pi 8 squared. Okay, before you go shouting out, think of what 8 squared is. It's not 16.
It's 64.
I said before you go shouting out, Jalen, it is 64 pi, and then my units. If it's talking about area, it's still talking about square feet. Okay? It is in terms of pi, so I don't have to be cruel, mean, and heartless and multiply by 3.14. Go ahead and do 2, 3, and 4. Read carefully. Ooh, Miss Lido's board is not scrolling down. Okay, pause and play when you're ready. Okay, so these are the answers. 196 pi centimeters squared. This one, I'm going to rewrite it, is 10.24 pi. I think that's missing. Oh, no, it's at the beginning. Again, centimeters squared. You always want to put the square after the units, not before it. And then lastly, 225 pi, this is going to be feet squared. Okay? The classwork you should be able to do, but the quick note I want to make on this is on number 11 and 12. So if you're with me, please, on 11 and 12. It is talking about semicircles, but those are full-on circles. And it's because it did not transfer well, the shading. You need to shade in these shapes. This again is on number 11 and 12. So this slide, there's no formula for that, but how could I figure out what would that be, Saranya?
Okay, so you take the area of the whole square, whole circle, and then you divide that by 2.
Divided by 2. Okay? You can check answers on Canvas.